Okay, guys, so let's go ahead and finish off a couple ideas here with box plots. So we're going to continue it here, guys. We may have another lesson or so in a couple future lessons here, but hopefully at this point we're getting a pretty good idea of how box plots work and the kind of information they can tell us about data sets. So today's lesson, again, it'll probably be a little bit more on the short side. It's a little bit more to the point. So we're going to take, what I'm going to do here, guys, I'm going to take probably one more lesson here that's strictly on box plots and kind of cut it up over a few days here. We got time, so we might as well just kind of incrementally go through this lesson here, since there's several pages on it and they have really good examples that I think will be good to reference and use. So I figure since we got the time to go over them a little more in depth, we'll just kind of take it piece at a time. Then that way I feel like we'll get more meaningful learning out of it. So we are going to be looking at, for this lesson, it is on lesson 15. Looks like that right there. I may have, like I say, I might have cropped it out a little bit to where we started up here. But we're going to be looking at some box plot information. And what we're going to do, guys, is we're going to look at a box plot, answer 4 questions about it, and then they're going to reveal a little bit of information about the box plot. And then based on the information they reveal, they're going to change things up a little bit and about that box plot and see if the answers that we gave on those 4 questions would change at all. Some of them, maybe they will. Some of them, maybe they won't. So let's go ahead and take a look and see what we find on these. So, and this would have been a pretty cool challenge, I think, for us to try here, guys. It would have probably been fun. If we'd had it in class, I'd have probably got some Tootsie Pops and given it a shot and had a nice little competition. Unfortunately, we weren't able to do it. If you want to try it on your own and message me about how many you got, we can kind of have a little competition and see who got the most. Just be a little fun with it. If you do decide to do it, please be honest about it. It's not fun if we're dishonest. So don't lie about it. Be honest. See if you want to try it. Again, just for fun if you want to. But here's what we would have tried. It said on classwork, you reach into a jar of Tootsie Pops. How many Tootsie Pops do you think you could hold in one hand? Do you think the number you could hold is greater or less than what the other students can hold? Is the number you could hold a typical number of Tootsie Pops? This lesson examines these questions. So if we had been in class, I'd have probably got a bag of Tootsie Pops and challenge y'all to see how many could you fit in your hand. Just like fit it wherever you can, how many you could hold just using one hand. And we could have seen who ended up being the one person that could hold the most. It'd probably been fun, but like I said, you can give it a shot if you want and just let me know how many you could hold. So on example 1, they call it Tootsie Pops, and it says 94 people. So a lot of people. That'd have been more like if we just about asked almost every kid in 5th and 6th grade to try this out. 94 people were asked to grab as many Tootsie Pops as they could hold. And we're assuming they just mean one hand. Here's a box plot for these data. Are you surprised? Okay. Here's a box plot. I labeled some information here just to kind of recap it. Minimum, maximum, Q1, median. I called it MED for median in the middle. Sorry if it's a little hard to read. And then Q3. So that's the information they give us. I just went ahead and asked right here, what do y'all think? So I guess if you're surprised by any bit of the data, like by what the box plot's saying. So if you want to pause the video, take a second and think if anything surprises you about this box plot. So if I were looking at it, if I were to answer it, I don't know. I'm looking through here. I'd probably say for the most part, one of the biggest things I'd be surprised at is how many someone actually was able to hold. Looks like someone was able to hold more than 40 Tootsie Pops in their hand. And I'm assuming they're talking about not the little Tootsie Pops, but the actual regular size ones, the ones you typically find in like a gas station or wherever you buy them, grocery store, in a bag, whatever. So I would be a little surprised by that. I'd also be surprised at how low it could get. Some people could only hold 7, but then again, I haven't tried this before. It may be easier said than done to hold them. But maybe for me, I might say the extremes are a little surprising. Um, but you never know. When someone's determined to try something out, you'd be surprised with how much they can handle. Particularly people like it shows here that can hold more than 40. So they're going to ask us a few questions. First one says, what might explain the variability in the number of Tootsie Pops the 94 people were able to hold? Well, again, if you look at that box and whisker plot or box plot, based on the numbers down below, and it looks like they list it from 5 to 45 is the range below, and it just about covers all that range. It asks, what do you think might have caused the variability? What appears to me, first off, that there is quite a bit of variability on this box plot, simply because it stretches pretty far out when you consider the numbers going anywhere from 5 to a little over 40. There is quite a bit of variability, I would say. So what do you think? What do you think are some things that would cause there to be a wide array of amounts that people were able to hold? What do you think? Again, you can pause the video or take a second and think about it. So just a couple of ideas of what I would think. I would think maybe hand size. Might be some guys in the class or anybody, maybe some girls, you never know, that maybe have bigger hands. So the bigger your hand, the more you can hold, kind of like people with bigger hands that can palm a basketball, and smaller hands not as likely to be able to do that. So hand size definitely would come into play. Maybe like dexterity. So like when you think of dexterity, like how well you can control your hands and like use them to like hold things, stuff like that. Or how flexible they are would be a useful thing. I didn't write this one down, but honestly, determination would be another factor. And I'm going to go ahead and write that on the list I had. So like determination to hold a lot, because a lot of people are competitive, so especially in y'all's group. There you got a lot of competitive kids in y'all's group, which I like that. I like that y'all are driven to do the best you can on things. So determination to hold a lot of Tootsie Pops. Maybe it's like a competition of whoever can hold the most gets the whole bag or something like that. Or maybe we give everyone one to begin with, and whoever holds the most gets an extra one or a couple, something like that. So, I mean, if I was being offered free candy if I want, I'd be doing the best I could to hold as many as I could. I'd be pretty determined to do it. So that's a possibility too. So when we're just looking at the first question, that's just a few I put down. Hand size, how flexible the hands are, etc. Determination to hold a lot of Tootsie Pops. Several things. Y'all could probably come up with other ones too, but that's just kind of the ideas I had. Okay. And then it says use a box plot to estimate the values in the 5-number summary, and that's number 2. So for that one, guys, on this one, I went ahead and drew an arrow. It was probably self-explanatory here, but I don't know really why they said use a box plot when they probably should have said use the box plot, because this is the one they're wanting you to look at. I don't really totally get their wording there, but they want you to find a 5-number summary. So take a second. Do we remember what the 5 things? Sorry about my hand there. Do we remember 5 things that are involved in a 5-number summary? Well, we should have minimum, maximum, Q1, Q3, and median. Well, again, if you have the box plot, it makes it pretty easy to spot. Now, the only challenge we might have here is estimation. Minimum is over here. And again, I don't know. Like I say, I prefer to put dots at the end of my minimum and maximum just because it makes it a little easier to see. But this is going to be a scenario I'm going to have to estimate a little. I would say if I were to estimate, and what might help you is if you drew a vertical line all the way down, it'd be close to the halfway point between the 5 and the 10. I saw it to be a little bit closer to the 5. So therefore, I said that the minimum was 7. And then let's see what I found next. The next thing I found was Q1. Remember, Q1's the left side of the box, and it is just a little bit in front of 20. So I went ahead and estimated and said it was about 18. Median or Q2, the one in the middle, is 20, I would call it. Pretty much right on 20, so I'd say 20. Q3 is a little bit after 20, but what I saw was it looked a little closer to 20 than 25. So I went ahead and said that Q3 was 22. And then if I look at the maximum goes a little bit past 40. Again, you might have seen it a little differently, but what I saw was it was a little closer to 40 than it was 45. So I finished it off by saying the maximum was 42. So there's my 5-number summary from that box plot. Keep that in mind because we're going to reference that again later on a later question on the assignment. So that's all for those two questions, 1 and 2. So let's look at the other side of this page. So if I'm looking at the other side of this page, we're going to answer a few more questions, and then they're going to kind of flip it around on us and give us a new scenario, and we're going to talk about what we think should happen for that. So keep that idea in mind. So it says on the second page of notes, it starts you off at number 3. Number 3 says, describe how the box plot can help you understand differences in the number of Tootsie Pops people could hold. Well, box plot helps you determine the minimum, maximum, Q1, median, and Q3. So you could either look at the box plot to kind of answer that, or you could look at the 5-number summary that you wrote down for the box plot to help you out too. And I kind of more use that simply because the 5-number summary and the box plot show the same kind of data. And I just wrote a few things down. I said first, as far as differences in the numbers of Tootsie Pops, according to the box plot, I wrote the maximum 42 and minimum 7 show a lot of variability. 7 and 42 are pretty spread out, so I would say there is a pretty good amount of variability here. And then, and I'll put this up in just a second. And then the second thing I said, and this kind of goes back to what we were talking about as far as the meaning of box plots and quartiles and stuff like that. It says I wrote that the box of the box plot. Okay, so if we're talking about the box right here, it's pretty small on this one. I said it showed that the middle 50% of people can hold between 18 and 22 Tootsie Pops. So remember what we were saying, guys. When we have it happens with the box plot too. But if you think about it, the quartiles cut your data into quarters. So you can think of 25% are between the minimum and Q1. The next 25% of your numbers are between Q1 and the median. The next 25% are between the median and Q3. And the last 25% are between Q3 and the maximum. So remember that the box on a box and whisker plot, and this is important, remember this, you may have a quiz question talking about this later. The box on a box and whisker plot represents the middle 50% of your data. So the middle half of your numbers, like if you had 20 numbers, the middle 10 numbers would all be they're represented in the box. So whatever the range is between the middle 10 numbers would be represented by that box, how spread out it is. So what I decided was, since the Q1 was 18 and Q3 was 22, based on my approximations, that means the middle 50% of those numbers land between 18 and 22. So that's what I put on number 3. And maybe you found some other pieces of information from the data. If you did, great. Feel free to write it down or mention it to me. And maybe you'll have some idea that I didn't think about that would be a good discussion point to have. Kind of up to you on that. But this is what I put on number 3. And again, it's open to discussion, guys. There's not just some clear-cut right answer here. That's just kind of patterns I saw on it. You might see something different than me. All right. Then on number 4, it says, here is Jane's description of what she sees in the box plot. Do you agree or disagree with her description? Explain your reasoning. Here's what Jane thinks. One person could hold as many as 42 Tootsie Pops. The number of Tootsie Pops people could hold was really different and spread out about equally from 7 to 42. About one half of the people could hold more than 20 Tootsie Pops. So let's just kind of talk about some ideas. I'm going to underline each statement, and then we're going to talk about whether we think each one is true or not. If they're all true, then obviously we'll agree with her. But if one of them's off, we'll have to, at least to a degree, disagree with her. So the first thing she said, and keep in mind that it's going to be helpful to look back at your box plot to figure this out. One person could hold as many as 42 Tootsie Pops. Well, according to my box plot, is that true? Could one person hold as many as 42? Well, my maximum is 42, so it sounds like, yeah, it is possible to hold 42. So I would agree with her. I would say on that first sentence, I'm going to go ahead and write right above that sentence that would be a true statement. So the first sentence, I underlined that first sentence, and right above it, I just said true. I'd agree with that. So I'm going to skip to the last sentence real quick. It says about one half of the people could hold more than 20 Tootsie Pops. Well, think about the box plot. The median cuts your data in half, right? Cuts it into an upper half and a lower half. So lower half, upper half. Well, the median is 20. If the median's 20, does that mean that about half the people could hold more than 20? I would say yes. Since the median cuts it into halves, that upper half should represent people holding more than 20. Since the median is 20, the upper half will have more than 20. So I would also say that last sentence is true as well. Keep in mind she wrote 3 sentences here. So on that last sentence right here, I said it's also true. Now, let's talk about that middle one. As you could probably guess, if I skip the middle sentence, it probably means that something is not true on that one. But let's just see. It says the number of Tootsie Pops people could hold was really different. Okay, I would agree with that. It did seem to be really different in that some people only held 7 and some people held as many as 42. So I agree with that part of the sentence. Then it says, and spread out about equally from 7 to 42. Okay, this is the part where I would say that I do not agree that it was spread out or it was spread about equally from 7 to 42. What that is trying to say, from how I understand it at least, is if you go along from 7 to 42, you're going to get about the same amount of people dispersed evenly all the way from 7 to 42. Okay? So if that were true, that would mean if we're thinking about the range from 7 to 42, that would mean that each section, if each number spread out about equally, that should make it where every section of your box and whisker plot are about equal, because it's showing that the spread in each quarter of the numbers should be about the same size if it's spread equally. If it's not, then if not very many are on one section, it might have to get pretty spread out to cover a quarter of your numbers. And then maybe if one section is really small, it's really small because that quarter of your numbers are all really close together, if that makes sense. So again, if you are looking at it, like, so for instance, if I'm looking at this box plot, this section, this side of the box from median to Q3 is really small, but keep in mind it represents 25% of the numbers, just like this whisker represents 25%, just like this other side of the box represents 25% of the numbers, and just like this whisker represents 25% of the numbers. So this, just because this is small, all that's telling you is you didn't have to go very far, only from 20 to 22, to represent 25% or 1/4 of the numbers. So 1/4 of the numbers right here are only 2 apart. So you're going to get several numbers that are just in that range of 2. But right here, this next 1/4 of the numbers are spread way out between 42 and 22. So clearly, one of those sets of numbers are way more spread out than the other set. If that's the case, then they're clearly not being shared equally, because one, like we say, is way further apart than the other one is in that little box. So I would have to disagree with her there. I put in my notes that I disagree because there could have only been a few people around 7 and 42. And most likely that's probably what happens, because a lot of times when you're looking at data, you may have someone that just stands way out above the other. But at the same time, you maybe have a really competitive competition and everyone's really close. But according to that box plot, I would have to say that since some of the sections of the box plot are bigger than others, it wouldn't be the case. So I'm actually going to take back what I originally wrote on these notes, and I'm actually going to write something different. So I'm going to say I disagree because some sections of the box plot are more spread out than other sections. So that is where I would finally get to my idea of whether I agree or disagree. Disagree because some sections of the box plot are more spread out than other sections. So she was close, 2 out of 3. Really, you could kind of think of it as 3 out of 4, because that middle sentence had 2 points. One of which I would agree with that beginning part, but I would disagree with the end of that sentence. Okay. So, with that being said, let's wrap these notes up by looking at one more idea. Look at number 5. Number 5 asks 2 things. It says, here's a different box plot of the same data on the number of Tootsie Pops 94 people could hold. Now, I labeled it already a little bit, but let's just kind of take a look at it. Notice something different. These whiskers aren't as spread out now. The box looks essentially the same. I went ahead and labeled the numbers. It still has the same Q1, median, and Q3 according to what I see. Just from estimating, they look virtually the same. But notice that the whiskers, they kind of cut off some numbers here. And instead of including them in the box plot, they just left them out. For some reason, they said, we're not going to count these. So it looks like 1, 2, 3, 4, 5 people were left out, and the whiskers got shorter. So that's what changed. And it says, why do you suppose there are 5 values that are shown as separate points and are labeled? Well, why do you think they might have left those 5 values out? What do you think? Feel free to pause the video and think about it when you get your answers started back up. So I think that what they were doing here was they said, okay, some of these people are causing this box plot looks really spread out, way out on the whiskers. It appears that there may be, so what we've talked about, maybe some outliers here. Maybe some are noticeably smaller than others, maybe stood out more, or maybe maybe there's a reason other than that. Maybe some of the kids had something go wrong when they're collecting them and caused them to not hold very many. Or maybe some kids were dishonest. They had a lot of them and they got disqualified. There could be multiple reasons why they didn't include their data. So I went ahead and just simply said possibly because they are very far away from the middle values. That's a possibility. You could go ahead and say it if you want. But again, there could be some unknowns. Maybe there's just some stuff that caused some inaccurate recordings, maybe. But this is all I wrote. But again, feel free to add some of the other thoughts that I said as well. Feel free to pause that to finish that statement out. So that's the first part on A. Now, one last question, and then we'll get to the homework here. So the last part of it says, does knowing these data values change anything about your responses to exercises 1 through 4 above? So here's what I did on this, guys. I assumed that since they took off a few data points on this, since they did that, and if from what I'm seeing, they're not including them in the whiskers. So I'm assuming they're just not going to make them part of the box plot. And with that information in mind, I am going to say that now the minimum and the maximum have changed because they have gotten rid of some of the smallest ones and some of the biggest ones. Okay. And what we're going to do is we're going to go back and think about questions 1 through 4 and see if any answers to our questions will change. Keep in mind, some of them might not. Well, if I go back to the first page of notes, question 1 said, what might explain the variability in the number of Tootsie Pops the 94 people were able to hold? Well, we talked about hand size, how flexible hands are, dexterity, determination, etc. Well, our numbers are still, from how I saw it, again, I'm just estimating here. I estimated the minimum to be about 12 now and the maximum to be about 27. Roughly, just kind of an estimation. If those are the minimum and the maximum, 12 and 27, I wouldn't change the answer to number 1 much. I still think the difference between holding 12 and 27 Tootsie Pops could be hand size, how flexible or how much dexterity you have in your hands. Determination, still same ideas. So I wouldn't change 1. So number 1, I simply said No change on number 1. Number 2. Well, number 2 originally asked use a box plot to estimate the values in the 5-number summary. Will those change if we take some numbers out of the extremes on the 5-number summary? Yes, it should. It should at least change the minimum and the maximum, because now the smallest numbers are taken out and the biggest numbers are taken out. So it should at least get those to be a little less extreme. So I said yes on this one. I said yes on number 2. If I would change number 2, and my explanation is just up here that I wrote the numbers now. Again, notice the minimum and the maximum changed from my original numbers on number 2. But from what I'm seeing, Q1, median, and Q3 aren't really changing. But some did change, so therefore my answers would change at least a little bit. Okay. Number 3 originally said, describe how the box plot can help you understand differences in the number of Tootsie Pops people could hold. Again, I was talking about the minimum and the maximum was shown. The box plot showed the middle 50%. Well, the box plot still shows the middle 50%, so that doesn't change. And it still was about between 18 and 22, that middle 50%. So that didn't change. Minimum and maximum changed a little bit, so maybe you could say the minimum and maximum changed in the box plot. But other than that, really not much changed. So I just went ahead and said probably not, because the overall ideas that you were saying on number 3 probably wouldn't change much. So again, I would say probably not as far as something changing on number 3. Then if I look at number 4, it's again kind of going back to what Jane said. If we're getting back to the same idea, Jane said she was trying to get at the idea that, well, first off, let's kind of talk. I would change a few things about what Jane said, because honestly, I'd say yes. A couple ideas. One, they could hold. This time, they wouldn't be able to hold 42 if we're assuming 42 is not part of the box plot. Now it appears that the box plot has a max of 27. So I would say, first off, what I would change is yes, could hold as many as 27 now. What else would be about the same? Or, different. The number of Tootsie Pops they could hold was really different. I'd still agree with that, 12 to 27. But that is honestly the only thing that's really going to change about it. Because if I go back up to this box plot, if I'm reading it right, the spread is still way more spread out on my whiskers than it is on the little sections of the boxes. Keep in mind, each section of the box is its own piece, not just the whole box together. So I would still say that's about the only thing I would change. So to finish it off on 3 and 4, I said probably not on number 3. And on 4, I went ahead and changed my mind and said yes. I thought I was going to have more than 1 point, but I ended up just having 1. It holds as many as 27 now instead of 42. And I just put the sentence, what do you think there, just to give you an idea of how you think they might change. Just kind of open the floor to you if you want to give your own ideas. But don't really worry about that. So, guys, that's all we have for the notes. So I want to go ahead, guys, and talk about what we're wanting to do as far as the assignment here, guys. So what we have on the assignment, and I'll try to make sure I edit it here. I kind of swapped lessons here. If you notice, I had a lesson 15 exit ticket for lesson 14. And then when I got to lesson 15, my exit ticket was more like, or homework was more on lesson 14. I kind of did it simply because the way the questions were worded, I kind of felt like they fit better being swapped if you were to use them for assignments. But just kind of read it real quick. And guys, again, I would highly recommend keeping in mind what the quartiles tell you. I'm going to give you again a little table on the side, kind of as a reminder here, as far as how the quartiles determine the whisker. There's a left side of the box. So it says the box plot below summarizes data from a survey of households about the number of dogs they have. Identify each of the following statements as true or false. Explain your reasoning in each case. Here's what I would say. If it's true, just say true. If it's false, explain why it's false. They give you 5 options. The maximum number of dogs per house is 8. At least half of the houses have 2 or more dogs. All the houses have dogs. Half of the houses surveyed have between 2 and 4 dogs. Most of the houses surveyed have no dogs. There's your 5 questions. Answer them true or false. Again, if they are false, please explain why. So that is the assignment for Monday's assignment here, guys. Please let me know if you have any questions about it. And if not, good luck on the assignment, guys. Again, message me if you have any questions at all, guys. I'll be happy to clarify. Again, we're having to modify this a bit, guys, where we're just kind of analyzing the box plots instead of drawing them. And I'll kind of try to, just to make it easier on us, find assignments that are more analyzing them and making them, just simply because it's going to be more challenging for us to try to make one on the documents we have. But again, if somebody finds a good way to make the box plots, an easy way for everyone to pick up on and not too many people get confused about, we may change it up and have some more assignments where you're actually making the box plots. We'll just have to play that by ear. So that's all I got for this lesson, guys. Good luck on it, and hope you have a good rest of your day.